Hello everyone. So welcome to the Method 24 a review for Midterm 2. Oh wait, I need to mirror my videos. And today we can go over like reviews for Midterm 2. So Midterm 2 review for Method 24. So we can go over some like the chain rules, like a logarithm differentiation, like implicit differentiation, like relative rate, a linear approximation if it's covered on the exam. Method 24. It's gonna be winter 2022. So the topic and introduce are those, and the first example it's a chain rule. So chain rule, it is the first most used powerful derivative rules in the midterm and the final. So I'm introduce the problem, just find f prime of x if f of x it is natural log of x to the cubic minus x squared minus 1. I think now you just understand that what is logarithm differentiation. So you know what is the derivative of natural log is, but this is the concept function. It is natural log of x cubic minus x squared minus 1. Then you will think that you need to use the chain rule. Well, using the chain rule, you need to think, what is the inside function and the outside function? So this time in the inside function, it is x cubic minus x squared minus 1. The outside function, that is the natural log of x. So I need to respond like a message. Okay. I see everybody join the Zoom review. So now it's the chain rule. So if you let u, it is x cubic minus x squared minus 1. The du, it is 3x squared minus 2x. Now we just say that f prime of x, it is going to be the du over natural log of x. So it's natural log of u, then d dx of hi. Hear me, all right? Wait. It's the d dx of 3x. Well, how can we x to the cubic minus x squared and minus 1. And now you're just gonna put back, and it's gonna be 1 over u multiply, and you know that what is the derivative of x cubic minus x minus 1? They just times 3x squared and minus 2x. And now once I have like a u, and you put the u term back here, and now we have it as f prime of x. And it's going to be 3x squared minus 2x. And plot back into the u, what you have is going to be x cubic minus x squared minus 1. And that is what you want. It is f prime of x. And number 2, it is still like another question on the derivative. So just find the slope of a tangent line. So we have a function that is y equals to e to the x cubic minus 5 times let's say it's going to be x, and this is a function. So find the slope of tangent line at x equal to 2. And so now you just see this is a product rule and a chain rule. So you have e of x minus 5. This is like f of x. And square root of x is going to be g of x. So when we apply the product rule, is y prime is going to be the e to the x cubic minus 5 prime times x to the 1/2. So it's like square root of x is the same as x power to the 1/2. And then we plus the derivative of x plus 1/2. And then multiply by this. It's going to be ex to the cubic minus 5. And then you should chain rule here again because you know what is the derivative of b of x. And then just use the chain rule when you see not anything that is. Yeah, just use the chain rule, and it's going to be 3x squared ex to the cubic minus 5 times x to the 1/2. And you have this going to be this. It's going to use like the power rule. I give 1/2 x to the negative 1/2. It's still going to be x cubic minus 5. So what is the slope of tangent line? It is y prime at x equal to 2. So we plugging x equal to 2 in there. And then you will get it is 12 going to be 12 EM. 12 is 3. And times like square root of 2. And then it's going to be 1/2 square root of 2 times e times e3. So that is the slope of tangent line at x equal to 2. So is there any questions? So please let me know if I'm making any mistake or something, or need more like, or I need to elaborate more on those questions. Hi, Frankie, welcome. So we just went some problem, and I'm going to introduce more. And now we're going to introduce some like, so I'll be good on chain rule, or you need one more. Okay, I'm just going to assume that I'm going to go over one more chain rule. So number 3 is find the equation of a tangent line. Of the tangent line to the curve this time we have is g of x gonna be natural log of square root of x minus 1, x plus 1 at x to 4. So when you see this like a nasty function, just don't don't be scared. So have natural log of this, then just chain rule and the product rule again. So the technique uses like a chain rule and a product rule. No. Chain rule and the quotient rule. Quotient rule. I'm so sorry about it. So G prime of x is gonna be so with the u it is equal to this chunk, and then we use like the quotient rule and the chain rule again. So we like so gonna be du of a natural log of x, and then the dx of this chunk. And now we just solve for this, and I label them as 1, so it's just easier to come back that when you solve any kind of work. So for 1, so if the dx of x minus 1, x plus 1, 1/2, we got to use the chain rule again. So like u equals to x minus 1, x plus 1. Then du is by the quotient rule. So it's gonna be x plus 1 is this bottom numerator. No, bottom in the denominator. And then the numerator is 1, and minus x minus 1, and the derivative of x plus 1 is 1. Bottom is going to be x plus 1 to the squared. So for, and this is just going to be is 1/2 u to negative 1/2. And then we put them all together, and we replace this u back here. I know it is kind of like I know it's kind of like annoying. So yeah, and there's don't follow like the chain rule. Sorry if I make any like a mistake, because not intentionally. So let me know if you have any questions. So for this, it's going to be x minus 1, the x plus 1, negative 1/2. And then you time x minus 1, this is going to be 2 over x plus 1 to the squared. That's just a variable mistake. Hey guys, I apologize for all like kind of a mistake here I made, because I thought just to use to like natural log of x, s, and x, and I forgot to change the variables when make the substitute when make the chain rule. I apologize for it. Now I have this mess. I need just to put back in there. So the g prime s, and it's gonna be 1 over u times this mess. So so I'm just gonna leave the So I'm just gonna leave it there. So it's gonna be 1/2 over x minus 1, then x plus 1 over negative 1/2 times 2 over x plus 1 to the squared. And plugging back the u, it is this chunk. I know it is annoying, right? And then g prime x 8 is gonna be 1 over x minus 1, the x plus 1 over 1/2 times 1/2 over x minus 1, and x plus 1, negative 1/2 times x plus 1 to the square root over 2. Wow, we solved this nasty functions. Now it's like geovax, that is, and if you plug in the x equals to 4, and you find it's like the slope of a tangent line. So g prime of 4, it is slope of a tangent line. So it's like the tangent line is always a linear equation. So when the equation is linear, so we have this point slope form. The point slope. So it's going to be y minus yo equal to m x minus xo. And now we know xo it is 4. We need to find y0, just plugging x into 4 layer. So for it's 4, not 5. Guys, forgive me to make those like a tiny mistakes. If plugging in 4, gonna be 3 and 5. So it's gonna be like natural log of square root of 3 over 5. Well, just leave them there because it's a nasty answer. So, and then for g prime of 4, it's gonna be square root of 3 over 5, and then times this. I'm gonna use my calculator. So it's gonna be 1 over square root of 3 over 5. Then we multiply it by 1/2 times this, gonna be 5. I'm gonna be 3 over. I am geez. Well, I'm sorry because I didn't know how to use calculator, so I'm just gonna write out this like a whole computation process. It's gonna be 1 square root of 3 over 5, and multiply by 1/2 over 3 over 5, negative 1/2. And plugging in 5, gonna be 25 over 2. And then we just call them because I actually just go over more questions, so I would just write them as a, that's gonna be a constant. So we just back to the equation tangent line. So it's gonna be y minus natural log of radical of 3 over 5 equal to a x minus 4. This is the slope of a tangent line and equation tangent line. Does this make sense to you guys? And or you need more questions? think because this function H is nasty because I don't spend like 10 minutes on typing them there. So, and now let's move on to logarithm to implicit differentiation to implicit. So the purpose of implicit differentiation, that is, if you're finding multivariate functions, is like, so if you have something that's like x squared of y minus y squared equal to 8, and you want to find what is the dx, it is what, and now it's like use implicit. So if you're take the derivative of function with the y, then you just write out like a y prime dy dx, because that's just implicit differentiation. So if you want to say it's going to be the dx over a y4, and it's like take the derivative here, it's going to be 40 cubic, but you want to, because there's no variable x in this equation, in this expression, so you want implicitly differentiate them. So y prime, just add them there. So they're going to be, I think, problem 4, I think. So find dy dx if x cubic and the y squared, and then minus ey, then plus x to the cubic equal to 2, just a random equation. And now you want to find what is dy dx. So what is the expression is? I think this is not just the same technique that we use, like the product rule here. You have x cubic and then y squared. So we just take the dx of x cubic y squared minus ey, then plus x to the cubic. And here's like a 0 because the derivative of a constant is a 0. Now just split them in a term. So we have this dy dx, so x cubic y squared. You first use the product rule. Use the product rule is like, it gets like the dx is going to be 3x squared. So when you're doing any differentiation term with x, there's no need to write out dy dx the term. But when you're doing the ddx over y something, then just write out like dy dx after like you do all the calculus here. So the first time we just apply a product rule. Now you just need it because 2y times x, so gonna be 2x to the cubic y dy dx, and ey, because this is intermediate y, so we just need to minus ey dy dx, and then plus is in terms of x, so just 3x squared equal to 0. And now if you want to find what the dy dx is, you need to combine the term with dy dx altogether in one side, and all the term without dy dx in another side. So we leave 2x to the cubic y dy dx minus ey dy dx and equal to minus 3x squared, then minus 3x squared y, and then we just move the term, and then we just do some calculation here. So you put them as dy dx of 2x squared y minus ey equal to a negative 3 squared and 3 squared of y. And then the dy dx and just move this to the bottom. That is your expression. So it's going to be negative 3 x squared minus 3x squared y over 2x squared y minus ey. And this is what you want, that what is dy dx is. Does this make sense to you guys? Or do you need to explain more? So feel free just to like speak out. So feel free to unmute yourself if you have any questions. Okay, let's do another one. So find the slope of the tangent line to this expression. At the point at the point is x to 0, y is 1. So when you find the slope of tangent line, so the first step it is, if you ever see slope of tangent line, just to find the derivative. So this is the first step. So we just use the product rule and the chain rule and the implicit differentiation. There's all three rules we need to use. If you ever see a function have x and y put all together in like implicit differentiation, use the product rule. If you see like inside function, outside function, then use the chain rule. So now I'm gonna do some like product rule. It's gonna be 2xy squared, then plus 4x squared y and a y prime. So now the y prime, dy dx, ddx are all the same. They're all the notation of the derivative. Now it's a big part. Now it's the chain rule. So if you're differentiating the x, then y is the constant. So just to move them out there. So we have the dx of x plus y. So you just need to do some like the chain rule, gonna be d du for natural log over natural log of u. Then the dx of x plus y. And then plus 3y squared y prime, it is this. So I'm doing right. Okay, I just want to make sure that I don't make any like stupid mistake here, because I just move because I move kind of fast. So please let me know if I make any mistakes, so to change it as soon as possible. So there's gonna be like natural log of so for this gonna be 2xy squared minus 4x squared y and y prime. And I have 1 over u, so it's gonna be so going to be 1 plus y over natural going to be x plus y and then y prime, and then plus 3y squared y prime. It is a 0. Now I have those a term and combine all the y terms there. So it's going to be 3y squared minus 4x squared y and minus 1 plus y over x plus y. And put together is y prime is going to be negative 2xy squared. Move to the other side. And now just look, we have like irrational functions. So we want to okay, so what is this 4x squared? So we have like x squared y squared. Oh, was 2x squared. Oh, sorry, it's just 2x squared. So mistake has been changed. Does this look normal? Thank you, because I apologize for all the mistake that I just making the rush. Now we want to make like common denominator, so it's x plus y. So we need to multiply everything by x plus y. Have 3y squared, then x plus y minus 2x squared y, x plus y minus 1 plus y over x plus y, and then y prime, it's gonna be 2x y squared. And then you want to find that what is the whole thing. You just move the term is like so this is going to be kind of a very, so this is going to be like a bit of a nasty expression. So I will just try to solve. So y prime it is going to be minus 2x y squared, then multiply by x plus y over this nasty expression. So it's going to be 3y squared and x plus y minus 2x squared y x plus y plus 1. Oh, should be minus 1. I forgot a parentheses here because it's like, yeah, I catch that mistake. I think this will be the kind of the final expression of y prime. Then plug in x equal to 1, x to a 0, y equals to 1. We got y prime is gonna be x equal to a 0 in that case. So the derivative is a 0. That means is the tangent line is horizontal. Wow, I solved this long nasty equation, but it's a horizontal tangent line. It's a 0. So is it so funny, right? Okay, so do you want one more question on implicit differentiation, or I move on to logarithm differentiation? Yep, I will do one more implicit differentiation. So question number 6. So I would say there's a curve. So John, did I answer your question? I'm gonna do one more question on implicit before move on to logarithm. So gonna be x squared plus 10y to the squared equal to 5 minus x squared to the squared. So find the equation of the tangent line. Find dy dx. And now we just have the all x squared. So we just expand the expression. Sorry if I write this have no margin here. So I need to rewrite them maybe in this space later, even later today. So we expand expression x4 plus 20x squared y and plus 100 squared, no 100y squared. That could be 25 minus 10x squared and plus x to the 4. Just need to move. No, I think we don't need to move. I think we just do implicit differentiation here. So I just do computation here. I will not write like everything. So just gonna do like 4x to the cubic because it's ddx everything. So don't need to write out y prime. But this is the thing. If you take the x prime, it's gonna be 40xy. But here it's gonna be like 20x squared y, and the derivative y is a 1. Y prime and plus 200. Guys, I apologize for there's like too many mistakes. I hope I can back on track here. With negative 20x plus 4x to the cubic. Now we have all the term with the y prime, and you want to put them all together, and we just define what is the dy dx, or like the expression is. So gonna be 20x, 20x squared, and then plus 200y, and the y prime it is 4x to the cubic minus 20x minus 4x to the cubic. Oh yeah, I'm right. Yeah. I would just make sure that I didn't do anything wrong. So and this is gonna be canceled, so we're gonna be like 20x to the squared and plus 200y, then y squared equal to negative 20 x minus 40xy. Now you know just how to find what is the y prime is. Just move them in the bottom. Actually, dy dx and y prime, they're basically actually same thing. So now if I want to say find the slope of the tangent line at 0.14, then just plug in x into 1 and y equals to 4 into this y prime, and that is your slope. Now let's try it. So what is the 1, 4 y prime, x equal to 1, y equals to 4. It's going to be negative 20 minus 160, going to 180 over going to be 4, going to be 320. No, 20 plus 800 is 820. As a roller coefficient of like 20 is going to be negative 9 over 41. This is going to be your slope of tangent line if it's at the point 1 and 4. Okay, so are you guys good to move on to logarithm differentiation? I think that's would be I have like 3 chain rule and 3 implicit. I would do like 3 more logarithm for all cases. Sorry, I was just replying to something in the Discord. Okay, so let's move on to the logarithm differentiation. So because number 7 is like when you use logarithm differentiation, it is I think logarithm differentiation, this part, there's not going to be like a hard problem. Is just to find the derivative. I think later I will make some harder question on implicit and the parametric derivative, because those are kind of the part that you may kind of the final or on midterm too. So find f of prime x if f of x is going to be x compute x. Okay, I'm just starting with an easier question, so just like give kind of like this sense like how just to work through the whole thing about logarithm differentiation. After this problem, I would go maybe like a harder questions. Does this work for you guys? Because I don't want to just go over too many hard questions, because I don't want to confuse you guys. So for any logarithm differentiation, so like it's like a function have a power of another function, but for e to the something, that is an exception. So that just use the chain rule. But now we just do something. It is y equals. So this is going to be in a form of y equals f of x g of x. So it's x and x. So the first step is going to be write out. It's going to be the natural log of y equal to gx is going to be x, and the natural log of x, because natural log of f, natural log of f of x, and then you want to take the derivative, just kind of implicit differentiation, but it's kind of logarithm differentiation. So we're just going to be 1 over y dy dx is going to be now it's the product rule, and logarithm, yeah, it's the product rule, and you know the derivative of natural log of x, it is so gx is going to be x have natural log of so give me 1 over the fi, so it's going to be x times like f prime of x. So it's like gonna be x times, so it's 1. And then v plus g prime x, it is 1. Natural log of f is gonna be natural log of x. So we can just simplify the term. So this is a 1, then plus natural log of x. Actually, to more kind of easier understanding of this, just y equals to x to the x. I don't even know that what is the y comes from, right? Because I don't want to write is f of x equal to x to the x, but I wrote on like y, so it's like people ask you why that views the y comes from, right? Okay, so here's what is the y is. And when if you want the dy dx, you just multiply the y to the both side. So you got this dy dx. So going to be y times 1 plus natural log of x. So this is just going to be x to the x, 1 plus natural log of x. This is the derivative. Does this make sense to you guys? Now I'm going to move on to harder questions. I guess ready for it? Okay, if you're ready, let's roll it. Question number 8. So I will try to go over as many questions as possible, just so during this session. I'll go over question till like 2:45, and from 2:45 to 4 p.m. is you ask me a question and I can just answer it. Does this work for you guys? So I will go over more questions in the next hour, and from 2:45 to 4 p.m. and it's your turn to ask me questions and I can answer for you guys. Okay, sounds great. Okay, so find the derivative. So going to be y equals to sine of x to the power of cosine of x. Now you know this is going to be logarithm differentiation, right? Where f of x, it is sine of x, g of x is a cosine of x. So we just follow the same process. We write them in the form of like natural log of y. It is and so going to be gx is going to be cosine of x, and natural log of fx is sine of x. Now it's the chain rule and implicit differentiation. And the product rule. So you know it's like the g of x just stay the same here. So they're gonna be so like the derivative of the sine is cosine of x. Sine of x here, then plus like a natural log. Because the derivative of cosine of x is negative sine of x. So we just said minus sine of x, natural log of sine of x. So just check the sign, check on like a negative signs, make sure to make sure don't make those mistakes on the midterm, because they matters. And then we just can rewrite the term, rewrite the 1 or dy dx. There's a cosine and a this is a cotangent. So it's cosine cotangent. Minus sine of x, like natural log of sine of x. And then like dy dx, just to put the y back. So multiply the whole thing on both sides, and we put the y in there. So the entire thing gonna be sine of x cosine of x. Or you want to write this is easier, so because like this into like rational functions minus sine of x times natural log of sine of x. Yep, that is what we want. So basically they're the same form, but I just multiply cosine in the numerator. But cosine over sine, it is cotangent. So does this make sense to you guys? So it's something just rewrite all like the trig forms of whatever is on there, and I just yeah. So do you guys want one more logarithm differentiation, or move on to reality right, or parametric derivatives, or parametrics?
I'm sorry, I joined late, so if we already went over this, don't worry about it. But did you by any chance do number 3?
One more logarithm, or move on to parametrics? Okay, so I would just okay. So I would do one more logarithm differentiation for you guys. To find the derivative. Okay, this is the function, and you want to find what is the f prime of x it is. So we need to use, and first of all, the chain rule, at the logarithm differentiation, and then yeah, I think that is all that we need to use. So for f prime of x, so we just use the rules. It's gonna be 4x to the cubic plus 4 to the x natural log of 4. So this is like derivative rules. So check back this. If we just use the chain rule, u equals to sine of e of x. Actually, chain rule used twice here. So use like the natural log side and sine of ex again. I know this is annoying, but well, I will solve it for you guys. Don't panic. I will solve this derivative. Trust me. And then ddx of sine of ex. Then just do the whole thing. Do 4x to the cubic and then plus 4x in natural log of 4 plus 1 over u. Kind of gonna be ex cosine of ex. So I'm doing right. I just want to make sure that I don't make any like stupid mistake this time. I mean, plot backing the u is gonna be so f prime x, so can be written as 4x to the cubic plus 4x in natural log of 4 minus ex cosine of ex sine of ex. Okay, now we solve this derivative. Yeah, I told you this is, yeah, it's solvable. Now we can move on to parametric. So can you guys give me like a reaction if you guys agree to move on to parametric derivatives? I just want to make sure that I cover everything that you guys need for the midterm. So because I just want to do as much thing as helpful. Okay, so let's move on to parametric. So we can move to 10.2. So it's like parametric derivative. So we have, so for parametric derivative, so actually so for now for any, so if you give any form of like xt and the yt and the derivative, it is y prime of t over x prime of t. And this is not what we usually expect in like other derivative. And if you ask for like a horizontal velocity, this is the y prime of t. It is a and it's like a numerator. If it's like a vertical velocity, that is the denominator. So it's for vertical. So it's going to be x prime t. It's a horizontal velocity. Horizontal velocity. It is. Oh wait. I made a mistake. Oh, why I'm just I just catch a mistake. Oh, I forgot. So y it is like a vertical movement, but x is a horizontal movement. Oh, in that term, I'm so sorry because I but if only for vertical tangent is when the bottom is to a 0. So when for vertical tangent, just to set this horizontal. yt is 0 because in a rational expression, if a numerator is 0, then the whole thing is 0. So that's why we just said the y prime t is 0. That's the horizontal velocity, horizontal tangent. Okay, let's start like another problem. On number 10, I think. Wow, 10 problem, man, like in 1 hour. That is like the fastest I've ever done. 10 problem. So if the parametric equations so it's have it gonna be xt, it is t4 minus t squared. And the y prime t, they're gonna be 8 minus t to the cubic. And it just find dy dx. Okay, I think there's just a putting, because like I usually start with like easier problems, so we just get the concept, because I don't want to just when we're doing a review just put like a hard one on it, because I want to make sure you guys understand, because I want to do something helpful for you guys. I'm not here to I'm here to help you guys, so yeah, so I'm just go easy but be helpful. So dy dx, it is going to be so dy dx, it is so basically it's like dy dt over dx dt. So it's gonna be y prime of t over x prime of t. That's how it is just came, because in terms of t, we're looking for dy dx. That's why we want to do this, is dy dt over dx dt. Now we just find each derivative. So it's going to be y prime t is going to be negative 3t squared over x prime t is going to be 4t cubic minus 2t, and that is what you want. Okay, that is the first intro. So let's try another example. So given xt, it is t squared plus 8. Yt, it is t squared minus t comma 3. Find the slope of the tangent line at the point, and we're gonna do 12.5. Okay, so this question, I bet maybe you see the question on the homework, and I know this question sometimes be hard. That's why I'm going over these questions. And do you ever wonder, we're still 12 and 5, and you have parametric equations. Okay, so now we find what t values make x equal to 12 and y equals to 5. So the first step you need to do is set t squared plus 8 minus 12, and you make it to be t equals to -2 and t equals to 2. if you set to t cubic minus 3 because 5, gonna be t is gonna be 2. So in this case, t equals to -2 is not a solution. So we just assume t equals to 2 is something because like we only find the one tangent line. There's no indication about whether to find 2 or 3 or more. So so we just assume n t is 2, and this is satisfying t values. The slope of tangent line is again it is dy dx. So how do you find dy dx? It is so and it's going to be y prime of t over x prime of t. So it's going to be y prime. It's going to be 3t squared. Going to be 2t. So going to be 3 over 2t. So it's just all right? Okay. Then plugging goes to 2, so going to be and then it equals to 2. So 3 is the slope of a tangent line at the point 12 and 5. So does it make sense to you guys? So it's like, so when you see like you have parametric equations and you have a point, and you want to find what is the slope of a tangent line. So the first step is just to set x equal to the x value, the yt set equal to y value. Then find all the t that satisfy all conditions here. Does this make sense to you guys? Okay, sounds great. So now I'm going to introduce like a new application of a parametrics. So if we have a parametric, so like the speed equation. So for the speed, so it's gonna be x prime of t to the squared and plus the y prime of t the squared under a radical. This is like a speed of an object if a parametric equation is just provided. So let's try another one. So it is so if it's like a baseball, if a baseball's location is defined by the parametric equations, so and I'm just to see it as going to be xt is going to be 21 t squared minus 20 yt is going to be t4 minus 4. Okay, so find the speed of the baseball. at t equals to 1. I'm not gonna do some proof about how this is proved, but like why don't I do like square root and square because this because the speed is only can be positive because it's how fast you move, but for like velocity can be negative because like because if you're moving backward, then you're traveling for negative direction. That means like velocity it is negative, but the speed is still positive. Because if you're moving, then you have speed, and the speed must be positive. And does it make sense? Because like, because speed is not same as the velocity, because the velocity can be negative, but speed cannot. Okay, I think I need it back on math because that is because for speed velocity because that is more like a physics. I don't talk about physics today, so we need to find x prime of t is 42t, and the y prime t is going to be 40 to the cubic. And then for the speed, I call them S1. It's going to be x prime of 1 squared, then plus the y prime of 1, all the squared. Then you have this going to be 42 times 42. Let's see. We have 42 times 42. We have times 2. We find the y is going to be 4. Yes, basically just like this. Yeah. So I'm just gonna leave at this form because I know it is divided by 4. So if you do divided by 4, I do think I should compute this or just move on. Because I know this can divide by 4. This is, well, 445. Yes. Going to be 2 square root of 445. Okay. So do you think all the things possible that's for parametric are all good? So do you guys want to move on to relative right? Or one more parametrics? Okay, for the relative right. So I'm not gonna I'm not gonna write down them all because it takes time. So I would just send all the link to all the questions that I'm gonna go over. So the first question I'm gonna go over is from Professor Perkins. Wait, it is not on there. Okay. I'm just finding the questions here, so sorry if it takes time. I would drop all the links here. Okay, so for basically, so this is the question I'm gonna go over now. Okay, oh, I should just send them to all, not only one person. So I'm gonna go over for Professor Perkins is winter 2018. It did really right. So this like the flashing light. So actually before everything, I just wanted has some like just like we call all like basics. So if it's like right triangle, and just make sure that you know the angles here. That gonna be an XYZ, and we should know gonna be x squared plus y squared. It is equal to z squared, and the area is gonna be 1/2 times x to the y, and the tangent of theta, it is y over x. If it's a cylinder, so it's gonna like a circle and like a height. So like if it's like this shape, so it's gonna be wait, I think it's like I think for surface area, it's gonna be 2 pi r squared. So 2 circle pluses like the long, like the all around. So gonna be the diameter and the height. So gonna be add them all together. Because this is like the, and the volume it is pi r square h. And if it's ice cream cone, yeah, this is. Sorry, I'm just being like a label everything, but yeah, and it's like the sorry. Is there like another message on the Discord? I'm just to check, make sure I don't miss anything. So okay, so for the cone, the volume, it's gonna be one third of pi r squared than h. And this is a sphere. So it's like this, like this sphere. Actually, I sometimes don't like those because they're annoying. But because I want you guys because I want to be happy, guys, I would do those annoying things. I don't really rate it, it is annoying. 4/3 pi r to the cubic. And I think that's all like the geometries that I think it is helpful for later rates. Okay, I think I should stop introducing all like the equations here. I need to go to questions. Sorry guys, I'm just spent like time on going over those like equations. I need to move on. Okay, so would you mind if I just share like screen, just like just introduce like really, right? Because like also, do you want me to just to share my screen to put the questions on there, so you guys can see yourself what's going on, or just write them on the paper? Because we had 20 minutes left. Damn, they're fast. 20 minutes. Okay, I have it right on the paper. So the question is like the flashlight on the ground from 30 meters from the wall. And the walking is like 6 feet, like from the wall. So it's like it's just so just put this like the Perkins. So gonna be winter 18, gonna be midterm 2. So put them is question 4. So it's like it's similar triangle here. So y is I didn't know why it is a height because it's a vertical like distance and the x and horizontal distance. And it's like it and Isabella it is here. And now we just so for all the related rights, actually first of all, they're annoying. And number 2, just to observe that what is and what condition we have and what do we want in the question. So what we have, it is because it's walking from the wall, so it's walking away from the wall, so it is decreasing, the x is decreasing, so it's like, so we have gonna be dx dt gonna be like, so gonna be -3. And I want to find what is dy dt when x it is 18, right? And now there's like a 2 triangles here, so it's similar to triangle. Wow. This triangle is like, it looks easy, but it is kind of a tricky, right? So we have gonna be 6/x equals to y over 30. 30 feet is the whole thing. And then you just set is the dt, then put in dy dx, and there's gonna be the dt of 6/x equals to the dt of y over 30. And now you're gonna be take the derivative, then in place that's gonna be negative 6x squared dx dt. I'm gonna be 1 over 30 dy dt. Now I have a dy dt in there, then just putting all the equations there. And then you put everything given, and just plug in dx dt, x, then we know that what is dy dt. Does this make sense to you guys? Also, a quick question. That is 3.10 on the midterm too for your professor, because I know some professor that doesn't cover 3.10. So if it's on midterm, I would go over some question on like linear approximation. Otherwise, still really right. Okay, sounds great. Sounds good. So is there anyone is anyone here have Beckel? Or all I guess all have Naharic? If it's no 3.10, wow. So where's the Beckel kids? Okay, so I'm just gonna put on the way toward the end of the of this review. So now I'm just gonna this just all like the geometry that I make here. So now it's like a 2:27. We have 15 minutes left. So do you want to go over more question or move on to Q&A, like the part of it? So do you want me to go over one more questions? Or we can just move to Q&A. Yes, I will go over another related right, but this one going to be not be on a. But this one, I'm just gonna. Yeah, I'll do like another one. I normally hate related rights, but I would do it for you guys. Okay, so I needed to this person really have I really erase this problem? No. Okay, so I will so I'm just gonna try to find questions that I can go over because I need to. Sorry, I'm just to find a question from. I try to find question from a web assign. I'm just to try to. I apologize for the waiting, because there's a whole like there's a whole list of like web assign problem here. Okay, okay, so I would just go over like one from like the old exam instead. Okay, so there are gonna be two cars because I can't find the good ones. I'm gonna like make one. So there are gonna be two cars, A and B, are and they're traveling. For car A moves at 80 miles per hour. From the east to the west. I think I found like similar problem here. So east from west. And car B moves from south to the north at 65 miles per hour. I'm sorry if I take too much time just to find like question, because I just well, because I know really the rate it is annoying. But again, I'm gonna do it for you guys. Okay, so find what rate are each car approaching each other when A it is 8 miles from the intersection, and car B it is 12 miles from the intersection. Sorry, I hate to write all like the long single line as problem here. So I just try to say I this intersection. So for any relative rates problem, so first strategy just like to sketch like a graph and label everything. So this is a triangle. So this is an X, this is a Y. In this case, it's like moving east to the west. So this way, so we have, so gonna be dx dt. It's gonna be negative 80. And then dy dt, it is positive 65. Because when it's in a triangle like this, moving upward, or it's like this way, it's positive. If it's moving like that way, or moving that way, it is all negative. So moving left or backward, then negative. If it's moving upward or forward, it's positive. And what we need it is dz dt. When x it is 8 and y equals to 12. And now we have is a Pythagorean identity. We have is gonna x squared plus y squared equal to a z squared. We need to find what is z. So z is gonna be 144 plus 64 square root of 208 square root of 208 280 divided by 4 it is 52 divided by 4 it is 13, so gonna be 4 square root of 13. So we have gonna be 2x dx dt plus 2y dy dt equals to 2z dz dt. Now we have this. You just put in x, because dz is what we want, and we have all everything labels here. So just putting gonna be 16 times dx dt gonna be negative 80. And plus gonna be like a 24, 65 equals to 8 square root of 13 dz dt. So gonna be, this is gonna be 1/4. Gonna be 8 square root of 13 dz dt. Then gonna be 280. It is 8 square root of 13 over dz dt. Then dz dt it is 280 over a squared plus 13. Yep, I can leave them there. Does it make sense to you guys? Yeah. 5 minutes. I don't think I have enough time to go over another related rates. So do you want to just end by 2:40, then move on to Q&A questions? It's like now it's like the time. Then that's time for you to ask questions, and I will answer it for you guys. We have 1 hour and 4. We have like an hour. So anyone does any questions? Concavity, that is 4.3. So for concavity is what type of a problem? Because concavity, that is section 4.3, that is not on midterm 2, but this is on the final. Okay. So we had like a full hour. Ask me questions. I'm gonna put them there. I'm gonna scan the file. Send a recording tonight. So you can. So everybody who missed today, just to watch the recording. And so do you have any homework questions or any in-class problem for Naharic that I can go over it? Okay, so how about this? So I will pull out my study guide and I went over my kind of so do you think I can win over my study guide so we have so we just spend the time? Because yep, I want to do more exposure to method 24 questions. You more prepared for the questions, more prepared for midterm 2. Here's my website. Okay. So I'm just gonna share my screen. Share the sound. I need to allow my Zoom to share the screen. Sorry if it takes time. So because I need to restart this Zoom. So would you mind if I end the Zoom and then restart recording again? So make sure we are not having issues. Because I didn't notice that I'm using the computer at Oligard. So I needed to do something. Okay, guys, I apologize for it. I need to end it now, but I will restart. I restart the meeting immediately.